I guess the first thing I kind of have to apologize. I was trying to, it's like environmental crusader here to keep things small on your page. But I'm not going to be able to fit this in on the slide that I have and make it easy for you to read. So you might be able to cram in your notes, but I'm going to put a new one here just so I can make it easier for you to read. I don't think I have the neatest handwriting, but at least this way it'll be easier for you to follow. So there's two different definitions of derivative. I will show you both, but the way I like to approach it is when I'm expanding, like here I'm going to have to do some expansions. If I use this definition of derivative, that means I'm going to have to do a bunch of expanding, like I'm going to be squaring this. So I like to go revert to the other definition I gave you, which is the limit as x goes to c of f of x minus f of c over x minus c. And again, the advantage here is that this will be 3x plus 1 minus 3c squared plus 1. So I didn't have to do any expanding, collecting, all that kind of stuff. It's a little simpler than in this case. So I'll tidy it up a bit. Forgot my limit. So that's going to give me the plus 1 and subtract plus 1. Those are out of this problem. I will have the limit as x goes to c of 3x squared minus 3c squared over x minus c. Hopefully at this point, if you were walking through it, you'd at least see that we can factor out a 3. Does anybody recognize a strategy here? Difference of squares, yeah. X squared minus c squared. So that means I could rewrite this as the limit as x goes to c of 3 times x plus c, x minus c, over x minus c. And that would be out of the problem now. I'm looking for the limit as x goes to c of 3 times x plus c, which has no discontinuities, no problems, no divisions by 0. I can just go ahead and substitute now, and I'll end up with 3 times c plus c, or 6c. And if you're thinking, yeah, I'm still not too sure how this works, what would be the derivative using our rules here? Yeah, just 6x. That's the derivative at x. You just found the derivative at c. Because x is approaching c, that means you've got 2 points on your graph. The 2 points are moving to a single point at c, which will give you the derivative, that line, tangent, at c. So you found the derivative at c here. Okay, this would be enough anyways if you ended here to show me that the derivative is 6c. All right. The other question I have here with square root, I'll use the alternate form. It's not that you couldn't use the same one we just did, but this one will show you the alternate form you could use, which is the limit as delta x goes to 0 of f of x plus delta x minus f of x over delta x. And I think it's x minus 5. So in our problem, we're going to have the limit as delta x goes to 0 of x plus delta x minus 5 and minus root x minus 5 over delta x. And hopefully at this point you remember this, one of your strategies for dealing with square roots. Anybody give me a hint? Yeah, rationalizing, multiplying on the top. What we're looking for here will be to multiply by this on the top and bottom. So now when I multiply those out, I'll just have x plus delta x minus 5 minus x minus 5. And on the bottom, it's kind of a mess on the bottom. I'll have delta x, and I've got this thing here, which is root x plus delta x minus 5 and x minus 5. So I'll collect up like terms, and I get limit as delta x goes to 0. So x minus x is no longer in my problem. Minus 5 minus negative 5 is no longer in my problem. So on the top of this fraction, all I'm left with is delta x, which is pretty handy because that's what's causing me the grief right now. So those are factored out of the problem. And at this point, as delta x goes to 0, it's okay if this goes to 0. I just end up with square root x minus 5. That delta x is no longer in the problem. So I'll have the limit as delta x goes to 0. On the bottom, it was root x minus delta x, or sorry, x plus delta x minus 5 plus x minus 5. And as I said, we don't need the limit anymore. This is just gone. So I've got 1 over root x minus 5 plus root x minus 5. So 1 over 2 root x minus 5. So you are responsible for being able to do this as well as recognize this. You're going to see we quickly fade away from this, except in the instances where we're practicing for your May exam. So the good news, I suppose, is that all that tedious work on limits, we're slowly drifting away from it for now. The basic rules of differentiation, you should be offended that I'm asking you to practice it because frankly it's pretty quick and easy, right? What would I get for the derivative of this polynomial? Yeah, someone else? What's the next piece? And okay. So this one here, I had suggested you consider rewriting. So before I do this, I would write it out as 5 over 4x squared. And that's like 5 over 4 times x to the negative 2. That way I can just apply power rule. There's no need to go quotient, chain, anything else, even though you know those techniques. This question's much simpler. You just need to help recognize it by rewriting. Even if you don't recognize it, those other techniques will work. It's just extra work. It's not necessary. So this will be negative 2 times 5 over 4 to the x minus 3, which is negative 5 halves x to the negative 3. And if you want, you could even move that to the bottom, so it would be negative 5 over 2x cubed. You are also, of course, responsible for knowing all your derivatives like sine, natural log, e, all those things that we've done. That includes those funny ones like secant and cosecant, etc. So let's just take a look here. What's the derivative for h? Okay, 3. Yeah. Your favorite derivative, remember, it does not change. E to the x is still going to be e to the x when you take its derivative. So if you are rusty on that, when you do your derivatives, you do need to know it. I can promise you, you will see those rules in your unit test. I need to know that you have learned those by now. And again, there's no formula sheet. You're going to be familiar with these, whether you like it or not, I suppose. But the good news is, again, you are going to use them for the whole year, so it's overwhelming right now, but you will have learned them as we go on for sure. Okay, product and quotient rule were the last ones that we talked about. So this one here, you could expand it out. You might think that's faster. That's fine. If you want to expand it out first and just use the power rule, you could. But we're going to practice product rule here. The derivative of the first piece would be 3x squared minus 3 times the second piece is just 1. And then the derivative of the second piece, oh, I'm sorry, I've already goofed. Thank you. I guess I just got excited. That'd be x plus 2. Now the first piece times the derivative of the second, which is 1. The second one, of course, we can't use any fancy expanding or simplifying beforehand. We do need the product rule to help us answer x cubed cos x, but it should not be something that you're scared off by. The derivative here, hopefully I get it right this time, would look like this. And of course, it's not a bad idea if you wanted to simplify this a little bit. It'd be 3x squared cos x minus x cubed sine x. Now the last piece that we have here, this one has no product or anything associated to it. It's just a regular old power rule. So the derivative is going to be just 2. But I do need to worry about the product rule here. And here's one thing that I suggest you do. It's really good to work with brackets so that you don't lose sight of the way those negatives are going to affect it. So what I would do here is I'd say I'm going to subtract, and now I'll put this product rule in the way I normally do it, which would be 2x tan x plus x squared secant squared x. Oh, I should have asked. I should have tested you on that one. Tangents derivative. You know it though, right? Yeah. Okay. Now, do you remember how to do it if you totally blanked? How do you get it back? Use your quotient rule, sine over cosine. You can find out that it is secant squared if you blanked out. Just rewrite it using sines and cosines. However, it's easier if you just know the derivative, because that's wasting your time while you're trying to answer questions on the tests. All right, so here, the careless mistake, of course, is that people would forget that the negative sign is applied onto here, and that I'm going to have 2 minus 2x tan x minus x squared secant squared x. That's why I was using the extra set of brackets there to help out. So quotient rule is very similar. I'm going to have you guys try these next 3, and then I'll review them with you. Don't worry too much about how far you go simplifying. Just see that you do know the quotient rule without having to refer to your notes. Okay, I'll catch up to you in a couple minutes. Okay, so let's review here and see where you're at. I'm just going to zoom in a little bit. Oops. Just to give a bit more room. The derivative is going to be the top, so 6 times x squared plus 1 minus, so this will be, 6x minus 5 times the bottom, which is 2x. And it'll all be over x squared plus 1 squared. So a good question was asked, how far do we need to simplify it? And I guess the answer is far enough. If it's on your multiple choice and you came across it, then obviously you need to simplify it enough till you recognize it. In written form, I would expect you to expand and collect the top, but that's about as far as you need to go. Written answers should be like a polished solution, right? You're not just showing the base, you're trying to actually get right to it, show me your depth of knowledge. But as far as your exercises go and practicing, that's where we're going to stop because we're just practicing the calculus skills, not the skills that you had from previous grades. So for this one here, derivative of the top is cos x. Then derivative of the bottom is 2x. And it'll be x to the 4 this time. And then finally, this one I have, let's put it over here. The derivative of the top is going to be 2 cos x times 1 plus cos x minus 2 sine x, 1 minus sine of x. So why don't we just take a look at simplifying a little bit more on this one and see if we get any better results. Let's see what happens. So this one here, if I expand and then collect like terms, I'll have 2 cos x. Oh, yes? Oh, thank you. Yeah, there's a square missing. So 2 cos x plus 2 cos squared x minus 2 sine x plus 2 sine squared x. So I definitely can see one thing that'll simplify. Yeah, this. Let me just finish writing this down and we'll pull that out. Yeah.
Just the one with the 1 minus sine x staying there. Doesn't it get cancelled?
Which one? This one?
Yeah.
Oh, yeah. Thank you. Because otherwise it's not going to simplify like it was supposed to. So it'll just be a minus here. Minus 2 sine squared. And that'll be a plus because it's minus minus. So clearly you should not rush like I just did. But this piece here, I hope you recognize that identity. It's like one of the most common trig ones that you come across. Cos squared plus sine squared is 1, so 2 times that is 2. So I can write this as 2 cos x plus 2. And then if I factor the 2 out, then the top and bottom are going to be reduced as well. And I would get 2 over 1 plus cos x. So hopefully that gives you an idea of, the farthest that you would go in simplifying if you had to, but using some trig identities there. Question?
Can we rationalize from the top, like from beginning?
So you wanted to multiply by 1 minus cos x on top and bottom? Yeah, I suppose you could. I'm not sure if it will provide an advantage in this case. Did it? I'm not sure if it makes the problem simpler. Was all you'd get a sine squared on the bottom, and it might be worth trying. But I don't think it removes the fraction. If it did remove the fraction, then yes, that would be advantageous. But I think it would need to be sine squared here for that one to work, right? Because then it would knock out anyway. Generally, you don't have to think quite that far ahead, but anyways. You have to be able to find higher derivatives. So the second derivative, we should start with the first. This will be 4 cos x plus 5 sine x. That negative and the negative sign that comes out of there, that's why I get a plus 5 sine x here. So the second derivative will be negative 4 sine x plus 5 cos x. And that leaves us at the last part of this unit, which was the chain rule. So again, this is something that I want you to focus your, generally people seem to do okay with the product and quotient rule. See how you do on the chain rule. All right, so I would rewrite this. Hopefully you have 2 x squared minus 1, and I would use the exponent, 1/3. So when I want the derivative, it'll be 1/3 x squared minus 1 to the negative 2/3 times 2x. And I suppose I could rewrite this as 2x over 3 x squared minus 1 to the 2/3. I don't think we need to play with it much more than that. The second one, I would go as 5 times x squared plus 1 over x to the 4. And then inside the brackets, 1 over x, I'm going to think about it like x to the negative 1. So this will become 2x. So negative 1 over, so it'll be x to the negative 2. So you'd probably write it like this: x squared plus 1 over x to the 4 and 2x minus 1 over x squared, like that. So I'll just let you know that my expectations are that these were chain rule with basic power, like exponents. They really only require you to apply the chain rule the one time. I'll be expecting you to look at times when there's more than one, maybe 3 functions, 4 functions, something like that, like we talked about earlier. So just know that this is just a refresher of chain rule. It does not go as far as I'm expecting. You should feel confident with things like we talked about earlier, like natural log, square root, sine of x squared. Something like, if you're okay with this, then I don't think you'd have any problems with chain rule. The next one here is a quotient rule question. It also involves the chain rule, however. So the derivative of the top is 3 times the bottom minus 3x. And now here's where chain rule comes in. So maybe in my margin here, I'll take the derivative for the square root of x squared plus 1. So it's probably most convenient if I think about it like that. And it's going to become 1/2 x squared plus 1 to the negative 1/2 times 2x. So those multiply by 2, divide by 2, that's out. And I'm left with, so that'll be x times x squared plus 1 to the negative 1/2. And then on the bottom, once I square that square root, I'm just going to have x squared plus 1. So here's one that I believe we could simplify. I'll give this a shot just to walk you through it. I'm just seeing this, the reason I'm thinking of simplifying it is I can see x squared plus 1, x squared plus 1, x squared plus 1. So I'm wondering if there's a way to get rid of that from appearing in all those places. So I'm going to multiply through and get rid of this. This one here is actually a fraction because of that negative exponent. So I'm going to multiply through by x squared plus 1 to the 1/2 on the top and the bottom. Again, if you don't like that, you can always expand your fractions, make your common denominator, pull your fraction back together, collect your like terms, simplify it, etc. But in this case, if I multiply through, I'm going to have 3 times x squared plus 1, because a square root times another square root is still just, the square root's gone. And then when I multiply this piece onto it, it's gone because I had negative 1/2 and positive 1/2. So it'll be minus 3x squared. That's the only piece left. I'll use a different color. So that's the only piece left because the negative 1/2 and positive 1/2 are out. And then on the bottom, this is like the exponent 1. So 1 plus 1/2 will give me x squared plus 1 to the 3/2. So overall then, that's 3x squared plus 3 minus 3x squared. And on the bottom I'd have x squared plus 1 to the 3/2. So these are out, and it does simplify a great deal. It's 3 over x squared plus 1 to the 3 halves. All right, and in the last example, you should remember when you see the natural log, or any kind of logarithm for that matter, we should simplify this as much as we can before we take the derivative. And in our case, that means we're going to go like this. We want the natural log of x plus the natural log of x minus 1 minus the natural log of x minus 2. If I was to do that and recognize it first, watch how easy this derivative is. 1 over x plus 1 over x minus 1 minus 1 over x minus 2. So if you're making a note to yourself, if you've already forgotten that when we've done it in class, you definitely are going to want to, it's going to be a giveaway. The derivative is going to be so hard that you would have to use this technique or you won't finish your test in time because it would take such a while. Yes?
When you change it into like the natural log x plus natural log x minus 1 minus
Yep.
So for that one, did you use product rule and quotient rule? Is that how you got that?
Okay, so there were no calculus happened until here. This is where calculus started. So calculus starts, this was no, everything outside of there, this is not calculus, this is just log laws. This is calculus down here. Because this became 1 over x minus 1, 1 over x minus 2. Okay? It doesn't have to be just log laws. It's a general rule that you should simplify as much as you can before you take the derivative because you know the derivative is going to get messy if you don't. So I just used log laws to simplify, and then I did calculus. Okay?